Morning. Hope you all had a great party yesterday. I was told to say this is my usual voice. It's not because I'm hungover or something. I actually didn't went to the party. Um, so I hope the phone doesn't ring anymore. It seems there's an emergency, but they will handle it. Um, so I want to talk a little bit about Python package development today. Um, Talk you through my journey or our journey in the past, what I saw in the past 10 years working with Python. Um, and yeah, have half an hour of like telling you about one of my favorite subjects, nerding around a little bit. Um, so maybe quickly about myself, where I'm coming from. I'm a mathematician by training, so I'm not a software engineer. I worked on data engineering, data science in the past, of course AI. However, I will not talk about AI today. And yeah, currently working on recommendations, sorting our search at About You. And I think I have more than 10 years of Python experience. In addition, like in the very early days, did like MATLAB. Really early on, worked with PHP or HTML, but yeah, just recently started because of my professional life. I started to work on Node.js a little bit more. So yeah, going a little bit more into software engineering and saw a few things that I didn't take for granted in Python, which I was pretty surprised they do have it over there in NPM log files. We will come to that later, which on Python just in the past 5 years evolved, I would say. Um, so I would say this talk is for you if you're like using Python, maybe not, but maybe you're interested in the recent developments. Um, you may already had some kind of package manager used. I hope if you're coming from this like math background as well that I had, maybe you just like install stuff. I think that's even different on R or MATLAB than on Python, where it's at least you see that there are some versions. But otherwise, yeah, you maybe have had experienced touch points with pip usually, pip tools maybe, poetry, PDM, UV, conda, or other managers. Maybe you did not yet hear about PEP 751. I'm pretty excited about that. However, I think the audience is not that much into Python, so I spend a little bit more time talking about Python development of package management as well, and hope I get to that point to hype out about that. Um, yeah, and maybe you want to learn a little bit about the log file format introduced here, or standardized here. So as mentioned, I talk a little bit about like Python dependency management, the historical journey, how to standardize log files, or what this topic is about. Just realized I didn't set up a timer, but that will work out, I guess. Um, some of my personal highlights, summary, and in the end, I guess we will have some time for Q&A. So, as mentioned earlier, or as touched upon briefly, Python's package ecosystem is pretty vast and complex. In PEP 8, so maybe just for those who are not working with Python, PEPs are Python enhancement proposals. So the community is discussing like how the language should evolve. That's a pretty nice thing. I will dig into that later in more details. And PEP 8, so the 8th PEP said in one of the points there should be only one way basically to do things. That's different here, right? If you look at how should I start with Python, there are hundreds of opinions on using virtual amps, using maybe some people say conda or pip or UV or poetry PDM whatsoever. And each of those tools here do have their own standard. Okay, the pointer doesn't work. So each of these tools has their own standard. And in the end, when you start to exchange software with others, you want to like have reproducible environments, right? If I hand over this piece of like scripts or software, I will want to make sure that you guys can execute it on your machine the same that I did on my machine. And that was tricky in the past. And this PEP 751, so there have been a few since the initial ones, aims to standardize the formats, how to like make sure environments are reproducible to support this goal. And this is the content of this Python enhancement proposal. So there was this document put out which says we propose a new file format for specifying dependencies. So I need this and that library to run this application or this package. And these dependencies should enable reproducible installation. So whoever does it has the same effects in a Python environment. So it's just about Python. And the format is designed to be human readable. That's pretty nice, I think. And machine generated. So it's like generated on the fly as you work with it. And installers consuming the file should be able to calculate what to install without the need for dependency resolution at install time. This is like lots of points, but I think the last one is pretty important, and we will see that soon, because in the past you were just like maybe exchanging, yeah, you need this and that file, and then library, and then when I wanted to install it, my installer tries to calculate what other dependencies does this have. So let's go through that. I wanted to do a demo, and then I realized maybe in cinemas the Wi-Fi does not work out. Apparently yesterday that was the case, so I took a little bit of screen videos, so we will go through that. That was in my really early days how I would set up a Python environment, right? When I want to work on something, I would create an environment, maybe pinpoint even to a special version if I'm feeling fancy, otherwise just taking whatever the system currently has. I would like activate this this environment so that I'm not using the global Python that most of the operating systems ship with, but use a specific environment. And I would start installing maybe, let's say, pandas, popular Python library for manipulating data frames, which is in the end about like tabular data. And I want to install the AWS extensions with it, kind of. So I want to be able to not just say pandas, read the CSV in and let me manipulate it, but I want to say read the CSV from my S3 storage bucket, and that needs additional dependencies, so other packages like from AWS, Boto3, S3FS, whatsoever, to make sure this works out. And when we look at how this works, so I hope this is readable, because from my end with the lighting it's a little bit difficult, but what you will see is that when I do this pip install, it will do a lot of stuff, you know, the stuff that I just said. It will try to find the latest version, it will try to find its dependencies, it will install all of them, so it's not just pandas installed, but it's as well, as you see, AIO Botocore, it's FS spec, it's S3FS, etc., etc., etc. So it's a pretty long list in the end, which gets installed, like 20 packages, and they are all now in some version existing. And let's now say there was a bug in FS spec. So we just saw it was, I think, 2025.10 version. And now I say, okay, I needed some older version. There was a bug. I want to downgrade. So I do this, right? In my environment, I just say, yeah, let's downgrade. If I just do it on my machine, of course, others needs to know about that. We'll come to that later. So in the end, I pretty soon lose sight of what I did, of this history of, yeah, I just downgraded it. So as you see here, in the like FS spec, it's currently .10, and if we now downscale it, okay, lower than .7, you will as well see, okay, there's a conflict now. And Python will tell you, at least, or pip will tell you, hey, you as well have S3FS, I think it is. Yeah, probably I have to look here. So probably it's S3FS, yes, which requires a different version. So you now have a conflict because of you just downgraded a single package. So you in the end want to do this for both together to make sure the resolution works out and the resolution takes into account that there's another dependency that as well needs to be downgraded, and not only FSS spec, but as well as 3FS, and that now works out pretty well. And now I need to keep track of, in the end, this one, right? These two things. And that gets more complicated the more time you work with stuff, and it's really not manageable. Damn it. Let me full screen that again. Perfect. So what we can do is we can just put it to a file, right? I can exchange the file, I can send it over to others, and I can just put these things into the file and say, hey, dude, please install this kind of dependencies. And I can keep track for myself as well to not create these conflicts anymore, because resolving those conflicts when you start doing things iteratively really gets a nightmare. Doing studies on Python projects that went insane in the end. The contrapoint, if I just put this in here, I don't know which version I installed locally, right? If I pass it over to you, you may install it a week later. There's already 2025.11 of the FS spec because they release monthly, or the Boto 3 stuff, I think, from AWS, they release really just like every day, several times, sometimes. But that works. In the end, at least it gives us a better idea of what do we have. So I can say, okay, here's my requirements .in file. I can, or .txt, it's usually called. I will use it later. That's why it's called in right now. Not the best practice here. And you will see that that it will work out the same way if I would do just like pip install pandas AWS FS spec below this. So it's the same in the end. Stuff which gets installed. Yeah. Let me take a short break so that you guys can think about it while it loads. And as you see, pip is sometimes a little bit slow on doing all this, like checking which packages are over there, checking what version I want, checking if I need a different version, checking dependencies, all this kind of stuff, even if we use the caching that we did here. So, as mentioned, it's slow. And that's how I came in touch with UV in the end. And that's something we see with lots of ecosystems right now. There's Rust toolchains being built for the ecosystem. That's happening in NumPy and in Node.js, for example, a lot. That's happening as well in Python. So there was Rough, which was a pretty nice, don't let me say something wrong, for Meta or Linter. And I used that for a few times already, or for a year or so. And then they announced UV in February 2024. Astral are the makers of this. And I got pretty excited because I was pretty happy with this linter already above the other ones that are available. And I was like, yeah, this could be a good thing. And what they said is UV is an extremely fast Python package installer and resolver written in Rust. I didn't care about that, but I was like, yeah, okay, extremely fast, I need this. And designed as a drop-in replacement. And that's interesting as well because I can just type, instead of pip install, I can just do UV pip install. I'm a little bit hyped about UV. Other package managers as well have their good features. UV has its contras as well. So don't take this for the only option, but I only focus on this in this demo. So before, this pip install requirements in took in the end 30 seconds or something. And when just putting UV in front of it, where's my cursor? Anyways, you guys see it. It goes down to 1 second. And this as well hold in production. So when putting it to our CI pipelines, we got build time down to like less than 1 minute instead of sometimes like 5 minutes for more complex projects, which is pretty nice for the developer experience as well. So you get really some faster stuff, but you as well get a little bit better dependency resolution in some terms. I will come to that later. And it will just like parallelize download stuff, which is nice as well. So I hope I put something in here so you guys can see it as well in action, how fast it is. In addition, it is as well a little bit more beautiful from the CLI output. So you will see, okay, these are the packages I got installed. It's a little bit easier to read. And that's already was for me the reason to use it, and later I explored several nice features about it that got me excited in the end about this log files and so on and so on. So what we did previously was we compiled our requirements. So there's a tool called pip-tools, which provides a pip-compile command, where you can just like take your requirements file, calculate in the end what would be in the environment with the pinned versions, so that you know, okay, it was 2025.11 from that version, it was maybe version 3 dot something from pandas. I think they are still on the 2.x track, but whatever. You will have all these listed in the requirements.txt. So that's already a good way to like hand it over to some others to make sure at least the packages seem to be the same that you install, that I do. And that's how we started using it, right? This compilation took forever and we just replaced it. So that was pretty nice. And we as well did replace just the usual pip install with it. But there's more about it. So I get more easy reproducible environments. I get that versions are guaranteed to work together. But I as well get, so we can see it here, that's blazingly fast, and you as well in this requirements.txt file then see like, okay, this version is coming from that, this is coming from that, etc., etc. So yeah, pretty nice, nice for our use case at that time, and requirements. And yeah, there's as well UV sync, which is, let me maybe quickly talk, I hope I don't cover this in another slide, but talk about indices. We can just quickly check it out. Yeah, okay, I will talk about that later. So then what we now can do instead of this virtual env creation, pip install, etc., is just put our like specification into a different like file than the requirements in file. Now it became the pip-project.toml file kind of, and instead of all these commands, like I think 3, 4, 5 commands that I did before, like creating a virtual env and sourcing it, like activating the env, installing stuff into it, etc., I can just do UV sync. And that's kind of my magic wand now that I can use to just do everything I want in a project, which is doing some pretty nice stuff. So as mentioned, I moved this from the requirements in file to a pip-project.toml, which contains other stuff as well, but mostly I'm just specifying my dependencies here. And I can now say, instead of syncing the environment, just say UV sync. You will see it creates a new environment over there at the .vn folder. I can as well specify the name if I want that, and it just installed everything and in the end logged this as well. So there is now a file which is looking pretty different than the requirements.txt file, but it as well contains exactly which version we need where. And it contains some new stuff, which is the size, the upload time, a hash of the package that was installed. So that is pretty nice for several reasons. And I want to talk a little bit about that. So I think the size, the upload time is something you may wonder, why do we need that? But the hash is, for those which are interested in security, probably quite easy to see, yeah, that's a good idea to put the hash in that file so that I can, when I download a new version, I can as well validate that this version wasn't like replaced by something else. So I can easily see, okay, this is still the one that Nico told me that should be there. The upload time as well, maybe some good indicator for, yeah, this looks valid. The size was some pretty interesting discussion point, because I was like, yeah, why do we need the size? And when you go to the PEP, you as well have a link to the discussion thread. I can always encourage you guys to look into this. It's pretty interesting. This discussion thread, there was like 10, 20 comments just about this parameter to have it in here. And it makes sense because when you have the size, you can stop after it kind of. Otherwise, there are some technologies to still have the same hash, maybe even, and override just like DDoSU, because of like just providing endless files or whatsoever when you request it from the remote server. I guess my screensaver turned on. Perfect. So I don't know what happened here with the links. Sorry for that. I was pretty excited to go back to LaTeX for this and didn't check that slide. So apparently something was screwed there. But like maybe going to indices. So in the corporate or enterprise context, you usually don't just want to say pip install pandas. You want to maybe have your own package, which you then don't put to the public PyPy, the public Python package registry. I forgot what the I stands about. You want to have your own one. And that's easy with AWS, with Google Cloud, with GitLab provides that as well, to just put your packages there. But you need to tell pip locally to install from some other place packages. And what can happen if you do this, that you then have like two indices, some private one and some public one, that like pip always just looked at all places where's this package that the user wants. So when I wanted a package, pip was like, okay, is it in the private one? Is it in the public one? There are some things that developed in the past that make it easier to specify, but pip still is a little bit dangerous because like I think our security got us actually trapped by just putting the same package name that we had internally on the public one with a 0.1 identifier or so, with no content, so there was nothing malicious in it, but you get this dependency confusion attacks that as well some big corporates had in the past. And the problem there was we had everything pinned, but like somebody used by accident the global Python environment, and that was, I think, still on 2 or already on 3 at the time, I don't know. And then our version was just not matchable to the local environment, and then it just did this, did install from the public one because yeah, it's there, why not? And that's what I like about UV. You can configure, again, you can configure that, or the default is as well, if a package is available, even if it doesn't match my current platform, my constraints, I will stop to look at other indices. And that was in the end convincing me to fully switch over to UV because that was for us pretty dangerous, the risk to get this dependency confusion attacks, and keeping it under control locally with people not that experienced with software engineering is a little bit difficult. So this puts a good security factor to like limit this risk a lot. So wherever the package gets found, even if I don't have the proper like version out there, I won't look for other versions on other indices. Pretty nice. And now we come to the PEP actually. So we see UV as log files. It's nice. It works. But how does this relate to the PEP? So there's this new standard that I talked about very in the early, which is like pylog.toml, which should provide this reproducible stuff. Everything kind of that this log file that I showed you earlier as well already kind of has, and we come to that soon. So in the end, yeah, nice points. Security hash verification. UV can export to this file, and it looks pretty similar as well. And I think I wanted to show you that one. So the specification in the end, or let me show you the file. So UV export, let's see if the seems to work. Perfect. So this file looks pretty similar as a log file, right? So if we like create the log file, you can have a look at it. It's kind of, let me move it over here. So these pretty much are similar ones. It has some nice tools. It has the log version. You see which tool created it, which Python version you need, etc. And you see all the packages with kind of the stuff that we just talked about, right? You see for each of the wheels that you could install, you see at the very end the hash, the creation time, the size, as well an identifier for which hash algorithm was used, which is pretty nice. And this kind of is how it looks like. And that's the specification. And what I really like about the specification, there was some really lengthy discussion. In the end, it took 6 years in total to get to this point. and it was the second PEP. The first one got rejected after lengthy discussion, and then this one got created. Again, after bringing everybody kind of to the table. I was not involved in that. I'm just excited just to mention that. And what I really like about this is it says why we do this, right? So we do have, this comes from metadata version, and you have lots of content why we do need it. And for example, for the packages, you see, okay, all these tools, PDM, Poetry, UV, do have in their kind of standards, they do have this like packages array, which packages are installed. And you as well have the name, you as well have the version, you sometimes have some markers on environments, and on the dependencies as well. Some people do this. And this is what I really like, right? You see how it got inspired by lots of different tools, lots of different projects, and how it in the end came all together. That is something you will as well see in the discussion when you go to it. So in the end, this was a PEP, so it looks pretty similar in the end. There's some reasoning, but then there's the same file format, so it got, in the end, just got copied over. And this discussion about the PEP until it got accepted was like a year or so, 3/4 year, with lots of like long discussions where it's from really famous people as well in the community. Like here you see Charlie Marsh, the creator of UV, with his team at Astral. So they, like Brett and the others, kind of got together to really discuss things in a way that the whole ecosystem in the end can work with this so that it gets adoption as well. And that's what I really like about it, right? That's a good candidate to really succeed. So what we do have dependencies, we have reproducible installation, we have something that is kind of human readable, I feel, and it's machine generated. And when I use it to install stuff, I can look up the hash. I don't need to source other dependencies. I can just like take whatever is there, check that it matches what's in the hash, etc., and just install it. So it's pretty nice. On the history, I already said that, right? 2021, the first PEP 665 got created. The discussion started, and after like half a year, they realized, okay, this is going nowhere. It's like too many different opinions. There were some stuff about certain distribution formats that were like critically discussed, and in the end, people have different opinions on how extensive this stuff should be. So it got on hold a little bit, and I guess in the background there was some discussion going on. And then 2024, 725, I did not yet know about that, but I saw like, okay, this proposal, like in the end, the proposal got created, and in March it got accepted. And then things started to roll pretty fast because they were already part of the discussion, right? So they already, all these packages knew, okay, this is going to come up. So in April, pip implemented it, which is pretty nice because that's kind of the go-to standard for beginners in Python. Then in 422, I was sitting at the PyData PyCon in Darmstadt and was like, what is this new release from UV? It was a lengthy release note, and it was like, okay, there's some new standard. And I got like pretty excited about that, and at that time kind of decided maybe I should talk about that. And then like PDM implemented it, and like now other tools as well discussing. So there are open threads on GitHub at pip tools, I think at Poetry as well, how to implement it, when, etc. So there's already quite some adoption. So we do have all these kind of things. The adoption kind of currently limits at most tools for like exporting to this file or importing from it, because like for example UV, Poetry, PDM, they all, well, like Poetry did not yet adopt, but PDM and UV all have their own like additions that they need. But in the end, it's already some pretty big step. So we do have them, they do work, and we have a single standard to which the community hopefully will kind of transition and yeah, lean towards that in the future. And what I really liked, as mentioned, is this discussion in the PEP. So you really see lots of interesting thoughts, me not coming from a software engineering endpoint, really got lots of pretty cool insights into how things should work from really people who do this for their like living to do really good software development. So it's pretty nice to read through these threads and get inspired about why things work as they should work. So I can all encourage you to try that out if you are interested in Python, like to look at those PEPs, maybe ask your favorite package manager to support it if it's not yet there, or you just like contribute on your own. You may want to try it out locally as well. And I think that's an important point, right? Like, check how your ecosystem evolves. It's pretty interesting to see these discussions happening. They happen for other things as well. So some of those PEPs are really good, fruitful discussions, even if they got discarded at the end because they don't find a common agreement, but you really learn a lot about stuff. And yeah, I guess that's it from my side. Some slides got missed, but all good.